Right. Welcome everybody to DSC 80 and Happy New Year. I'm super excited to be guiding you all through DSC 80. It's a really fun course. And I just realized it's the first time saying Happy New Year in person because, this is only my second year at UCSD. And last winter we started remotely. So we never had a first class in 2022. But anyways, you've made it to the right place. I don't know if you noticed, but right outside the room, it says Suraj Rani Center. And I was like, the people assigning classrooms must have seen this. Like, there's no other way they would have put a class for 100 people in a 250-person room if it wasn't to, name the building after me. But anyways, some introductions. Though this may not be necessary, I checked the data, and 80% of you took DSC 10 either with me or in a quarter in which I taught it. So that's fall 2021 or winter 2022. So to many of you, hi again. But to those who I haven't had the pleasure of meeting, my name is Suraj Rampure. This is my second year teaching at UCSD, and this is my second quarter teaching DSC 80. As I mentioned, I've taught DSC 10 before. I've also taught 40A, a seminar, DSC 90, and this year I'm also running the senior capstone program, which, as the name implies, you will take in your senior year as a data science major. Outside of the classroom, I don't do much. I like to watch basketball or go to new restaurants on Convoy or FaceTime my mom back home just so that I can see my dog. This was him over the break when I went back to Canada. As you can see, it snowed quite a bit. And every 5 minutes, he just wanted to go outside, play in the snow. And then we'd have to clean his paws every time. And I didn't like doing that. It's not just me that you're going to interact with this quarter, though. We also have 11 tutors, which is quite a sizable number for a course that, like I said, only has around 100 students. So we're really hoping that you will all be able to gain some, personalized instruction in office hours and on ed with the help of our tutors. Many of them are here with us today. I'll just let them briefly introduce themselves.
Hi, I'm Wei. I'm a third-year data science major student, and I think I've been in a lot of classes you have taught before, so nice to meet you again.
Hi, I'm Yuxing. I'm also a third-year data science major student, and this is my second time tutoring data science 80, and also tutored this course last quarter, and I'm happy to help all of you in my office hour.
Hello, I'm Nicole. I'm a fifth-year data science major. This will be my fourth time tutoring DSC 80, and I'm looking forward to working with you all this quarter.
Can I just say, this happened last quarter too. When I introduced myself, nobody clapped. But when all the tutors introduced themselves, everyone clapped. I'm just saying.
I'm nervous. Hi, I'm Tiffany, and this is my first time tutoring DSC 80. I'm really excited to meet you all. Feel free to reach out to me if you have any questions.
I'm Doris. I'm a fourth-year DSC major, and this is the first time I'm tutoring DSC 80, and I'm excited to work with you all.
Hey everyone, I'm Yash. I'm a fourth-year data science student, and this is my seventh and final quarter as a tutor, and second time for DSC 80. So I look forward to meeting all of you.
All right. So everyone's email is on the staff page of the website, and feel free to reach out to any of us or come to office hours. So I like starting off lecture one in these courses with an overview of what data science is from our perspective. When you don't know what something is, typically you Google it, right? Or maybe now you'll ask ChatGPT, which we'll look at in just a bit. But yesterday I Googled what is data science, and you can see there's no one agreed upon definition of what data science is, but what is common amongst all of these search results? Yeah, you see a lot of Venn diagrams, right? Some have 3 circles. This isn't quite a Venn diagram, but it has 7 components. This one has a lot. Everyone seems to have their own definition of what data science is. So we can start with one answer we gave you, which is back when you took DSC 10. The definition of data science we gave you in DSC 10 was that it's about drawing useful conclusions from data using computation. And how did we work towards the goal of teaching you about data science in DSC 10? Well, if you think back to what you did in DSC 10, you used Python to explore and visualize data, right? We introduced baby pandas. You learned how to, merge data frames and group data frames and draw bar charts and draw histograms. You did all of that. You then learned how to use Python for simulation, and you used the simulation as a tool to make inferences about some population, learn something about some population using just data you had access to in a sample. And then towards the end, you learned how to make predictions about the future given data from the past, and that's just a fancy way of saying you learned about the basics of linear regression. Now, I'll show you a few more definitions of data science in just a second, but what I wanted to point out was that you are going to revisit all of these things in DSC 80 just with a bit more rigor now that you've also completed DSC 40A, DSC 20, and DSC 30. So when I think of what the definition of data science is, this is the Venn diagram that comes to mind. Okay, it's the intersection of hacking skills or programming, math and statistics knowledge, and domain expertise. Okay? And where you really don't want to lie, and the reason we make you take so many math and statistics courses, is that you don't want to lie in the intersection of being able to program and knowing about things in the real world, but not knowing the theory behind machine learning tools, for instance. Right? You really don't want to lie in the so-called danger zone. And that's why you take so many theoretical courses. I just wanted to point that out. Now, that's the Venn diagram that I think of. But as we saw when we Googled what is data science, there isn't just one data science Venn diagram. In fact, there's a whole article about different data science Venn diagrams and how some are, more representative of one kind of data scientist over another kind of data scientist. I encourage you to read this article if you're interested in it. But what I'll encourage you to do is, take the courses that we are giving you seriously, because what they are doing is they're allowing you to, build a strong foundation upon which you can dive deeper into whatever area you're most interested in. Okay? Now, perhaps a bit more concretely than thinking about what a data scientist is, we might want to study what a data scientist does. And so this is a survey from 2016 by O'Reilly, a publishing company, where they administered people under a variety of job titles, but all sort of considered themselves data scientists. And they asked them, what do you spend your time doing on a daily basis? I'll zoom in here, and I'll zoom in towards the bottom here. What is the most common task you see that data scientists reported that they did? Exactly, basic exploratory data analysis. Okay? And so, we're going to touch most of these points in DSC 80, but I wanted to point out that data science isn't just all about machine learning and AI or whatever. A lot of time is spent just getting your data into a usable form. Taking snapshots of me? Anyways. Now that was in 2016, okay? Now, I was trying to update the data for this lecture, and I was like, it would be nice if there was a 2021 or a 2022 version of this same survey, and maybe the percentage of respondents that said exploratory data analysis changed, and maybe machine learning changed or whatever. They did a survey in 2021, but it doesn't have the exact same information. Instead, it was more focused on salary, and you can read the survey if you're interested. It talks about the salaries of data scientists based off of their primary language, based off of what tool they use for statistics, things like that. One interesting question that they had was, what technologies will have the biggest effect on compensation, so salary, in the coming year? And this time, what was the most common answer? Clearly, machine learning. Right? Now, that's not the most common skill that data scientists in 2016 said that they had to use, so maybe this is a sign of changing times. I don't know. It's also worth pointing out that the survey isn't called the Data Science Salary Survey. Now it's called the Data/AI Salary Survey. Okay, just worth pointing out, and I encourage you to take a look at both of these surveys. They're full of information. So, what is my perspective on what a data scientist is? Well, I like to think of a data scientist as someone who is trained to ask and answer questions using data. Now you may say, hey, I could answer questions using data in high school or in DSC 10. If I wanted to know the average height of the 4 people sitting right here, that's a question I could ask, and I could answer it without much effort, right? But there's no uncertainty there, right? These 4 people, these 4 kind tutors who have showed up, they all have heights. We could measure them, and we could find their average height. But what we are training you to do as you take more and more courses are to ask questions that have more and more uncertainty, like what's the average height of everyone at UCSD, right? That's a bit more uncertain, and we're equipping you with tools to answer those kinds of questions. So kind of just for fun, just to motivate the kinds of things we are going to do in DSC 80, let's look at some cool applications of data science. Who still plays Wordle every day? Okay. We're a rare breed. Now, I initially put this slide in the lecture when I first taught DSC 80 last spring, and even at that point, right, the first lecture was in like April, Wordle was declining in popularity, but more people raised their hands than just raised their hands now. But at the time, someone analyzed Twitter data to determine, the average number of guesses per word based off of the grids for Wordle that people shared on Twitter. And you can see for easier words, or more intuitive words, the average number of guesses based off of what people shared on Twitter was lower than for more complicated words. Like dodge, for instance, while it's a semi-common word in English, it's kind of weird to guess within the constraints of Wordle, right? Because you wouldn't put a D or a G in your first guess, for instance, right? Okay, and so like I said, I put this slide in the class last spring, and when I was preparing for this lecture over the weekend, I was like, I can't just talk about Wordle, because as we demonstrated, most people don't play Wordle anymore. So I was like, is there data about the fact that people don't play Wordle anymore? And of course there is. And so again, using Twitter data and Google Trends more generally, there's a whole study about how often people were sharing their Wordle grids per month. And you can see it peaked in January and February. I forget the exact date that the New York Times purchased Wordle, but I think that was around the peak, and it was around February or March. And you can see that since then, there's been a gradual decline in the number of daily Twitter shares of those Wordle grids. Okay? Worth thinking about. Okay. Here's a fun example. ChatGPT. You've almost certainly heard about ChatGPT over the past few months, and it's what's called a language model. Now, I'll say right now, it's in the syllabus as well, you cannot use ChatGPT or Google Copilot or anything like that for the assignments that you have in this course. I mean, that would just be a complete waste of your and your parents' tuition money, right? Like, it just doesn't make sense. But what I will say is that in Project 4 of this course, you're going to build your own language model. I mean, it's not going to be as powerful as ChatGPT, but it'll be able to do similar things, right? The core of these language models is you give it a sentence or a sequence of tokens, and what it does is it predicts what next token it should display. And your language model is going to do that too. What I want to do here is just show you one of the cool ways in which ChatGPT is not perfect. Okay, so here's the question I want to ask it. A line parallel to y equals 3x minus 2 passes through the point 6, 10. What is its y-intercept? Or maybe I should say, what is the y-intercept of this line? So before we ask it, let's make sure that we can answer this ourselves. What is the y-intercept of this line? What is it? Well, let's see. If it's parallel to y equals 3x minus 2, it has to be y equals 3x minus something, or plus something. We agree? It has to have the same slope. So then 3 times 6 plus something has to be equal to 10. 3 times 6 is 18, so that something has to be negative 8. We agree? So hopefully this tells us negative 8. But let's see. Oh, no. No worries. Just got to do this again. A line parallel to y equals 3x minus 2 passes through the point 6, 10. What is the y-intercept of this line? Okay. Yeah, okay, that's true. It has to look like y equals 3x plus something, where that something is the y-intercept. You can see in the lecture slide. I tried this exact query yesterday, and it said -4 instead of -8. Okay, and then you can see the proof here. Okay, so the live example is not great, but you can see yesterday, when I asked the exact same query, it said -4, right? And you can see where it messes up. The first two sentences are okay, but then it simplifies 10 equals 3 times 6 plus b incorrectly. Right here, it's supposed to give you -8. Now it does, but yesterday it didn't. Though, what's still wrong with its answer here as well, in addition to the -4 being wrong? It's not quite wrong, but like the fact that it gave us -0 is just a little weird, right? It's not technically wrong, but it's kind of odd, right? And this reflects the fact that ChatGPT, it doesn't have a calculator built into it, right? It's just trained on a bunch of text, right? But the point I wanted to illustrate, which I'm kind of sad doesn't work anymore, is when you change the question, even though the math underlying it to us is the same, how it approaches it may be very different, right? So the only difference here is instead of asking what is the y-intercept of that line, I asked what is the equation of that line, and you can see it did everything correctly, right? It used this formula that I didn't tell it about, the point slope, or the point intercept formula for an equation, and it correctly identified that the y-intercept is -8, right? Whereas, I did these two prompts within 10 seconds of one another, and the math is the same, but what it does is very different. Just something I wanted to show you. Okay. Now, one thing we will try and bring up repeatedly throughout the course, though I don't think we do a good enough job at this yet, is emphasizing the fact that, while this example I just showed you, finding the y-intercept of a line seems silly, it doesn't seem that impactful, what you are going to start doing, especially once you graduate and you work in industry as a data scientist, or you do research in data science, is that the work that you do and the outcomes that you find will have impacts on real people's lives. So a common example that we've seen over the past 3 years is COVID case forecasting, right? Several research organizations tried to predict how many COVID cases there would be in the next month, and then they would use that to either tighten or loosen public health restrictions, right? So you can see the immediate impact on people's lives and livelihoods, as a direct consequence of work that data scientists do. What about admissions and hiring, right? Over 100,000 people apply to UCSD for first-year admission every year. Do you think someone's reading all 100,000 of those applications? Probably not, right? And so that's kind of a scary thought, right? Who's in charge of deciding which applications get read, right? It's another application of data science that obviously impacts people's lives, right? It impacts whether or not you get to go to UCSD, right? You can think of more and more related examples, each of which has a varying degree of significance on people's lives. But the point I want to drive home is that, the stuff we're doing in this class, for us, may just live in a Jupyter notebook, but when you go out into the real world, it'll actually impact what decisions people make and how people live their lives. Okay, so just remember to think about the broader societal impact of the work we are doing in this class and in the data science major more generally. And that relates to this other point I wanted to drive home, which is that we're not teaching you to just memorize these commands in scikit-learn or in pandas, or memorize these random statistics formulas and plug things in. Right? There's computers that can do all of that for you. Right? We just saw that ChatGPT, it wasn't perfect, at least when I tried it, but it can do a lot of this for us. Right? But what it can't do is think like a critical data scientist. And that's what you're here for. Right? That's what we're training you to do. And try and think more critically about the problems that you're looking at, rather than just guessing at random syntax until it says grader.check, all test cases passed, right? Try and think a bit more deeply about what it is we're doing. Okay, so now that we know, what the purpose of studying data science is, let's think about what exactly it is we are going to do in DSC 80. So if we had to summarize it in one sentence, what is DSC 80 about? Well, it's about dealing with messy, ambiguous, and complex data, okay? And I think the best way of describing what it is you're going to get out of DSC 80 is thinking about where you will be in 2.5 months from now. So in 2.5 months from now, you'll be prepared for a lot, right? You will certainly be prepared for internships and data science interviews, right? You may already be prepared for that, but after DSC 80, without a doubt, you will be prepared for that. You will be able to produce really meaningful personal projects. You'll do some of those in this course, in projects 3 and 5, but you'll also be equipped over, say, spring break or over the summer or whatever, to build cool projects of your own that you can put online for other people to see. You're going to be ready to do that as well. And of course, since this is the final lower division course that you're taking in data science, you're going to be prepared to excel in the upper division. I'm pretty sure, let's not record this. Okay, and so here I have a rough schedule of what you're going to learn each week in DSC 80. Now, I won't read it all out to you. You can see it here. But here's what I'll say. When I taught DSC 80 for the first time last spring, I'd say about 40% of this stuff I did not know. I learned it the night before lecture, or maybe a few nights, or the night before we had to release the lab for that week's lecture, right? And I think I did a good job at acting like I knew what was going on. I know it now though, so it's okay. But here's my point. Since I went through the process of teaching DSC 80, I myself have become much more confident in my skills as a programmer and as a data scientist. There's just way more that I can do personally for my courses and just for random stuff that I work on that I couldn't do before I went through DSC 80. And now that you're going through that process of learning the stuff in DSC 80, I hope that you will also reach that state of being confident in your abilities and being able to tackle a wide variety of problems that you just run into in your day-to-day work out in the wild. Okay, so let's talk a bit about course logistics. For one, everything is going to be run through the course website, dsc80.com. You've probably already navigated to it, and if you've taken one of my courses before, the template looks familiar. Okay, just a few things I'll point out. I'll get to this in a few slides, but all of the course content you are going to access by pulling our public GitHub repository, which is linked here. You are going to pull this repo to access everything. And so once we're ready to release our first lab, which we will do tomorrow, to access it, you'll pull it from this repo. And then you can just maintain a copy of this on your computer, and every time we release a new lab or a new lecture or a new project, you just go into this repository on your computer and run git pull. Okay, we'll walk through some of the logistics of this. When we release Lab 1, I'll record a video talking about it, but I'm just letting you know we're not going to use DataHub unlike in DSC 10. Well, I should correct that. Using DataHub is an option. It's one of the ways you could access the course content, but there aren't going to be magic links that you can click that just open Lab 2 or whatever. Even on DataHub, you're going to have to interface with Git, and my suggestion is just follow the instructions on the course website under the tech support tab to set everything up locally on your computer, because when you graduate, you're not going to have access to DataHub, but you will still hopefully have your computer. Right? It's an important skill, so I think it's a good time to learn it. With that said, I think just to make it easier for you to take notes on the lectures in person, I will post HTML previews of the lecture notebooks on the course website. So if you have like an iPad or something like that, and you want to take notes, you can just click these. What else is here? There are readings associated with many of the lectures. Of course, there's the syllabus. Make sure you read that. There's our calendar, which has our office hours schedule. You can see that the office hours are concentrated around the deadlines, which are Mondays and Thursdays. I'll talk about that more in a sec. There's the tech support tab, which I just told you about. You should follow the instructions here to set up Anaconda locally. We have several resources. We're working on a new way of formatting past exams. We will post those in a few weeks. And then, like I mentioned, the staff page with everyone's bio. Okay. In addition, make sure you're active on Ed. I believe everyone here received an invite. Let me know if you haven't. It's like the new Campus Wire or the new Piazza is the easiest way to think about it. That's where all announcements are going to be made, so make sure you're active there. Gradescope is where you're going to submit everything, and we're not going to use Canvas, okay? In addition to following the instructions on the tech support page, make sure that you fill out the welcome survey. That's where you can tell us if you have any conflicts with the exam times or things like that. Okay, I already talked about this. You're going to access all content by pulling this Git repository. I also already talked about this. You could set up your environment on your own, or you could do it on DataHub. My recommendation, do it on your own computer. Okay, but DataHub is there as a backup, and when you go there, DSC 80 Winter 2023 should be an option. Okay, into some of the nitty-gritty details. You're going to learn in this course by just getting your hands dirty with practical data science ideas. And that's reflected in your grade. 75% of your grade, in fact, a little bit more, comes from the assignments. Okay, so 35% of that comes from the weekly lab assignments. Now, when you took DSC 10 and maybe DSC 20, labs were like baby homeworks, and you had a lab and a homework each week, right? Labs in DSC 80 are not baby anything, okay? Like labs are your main assignment that you're going to have to do each week. Okay, think of it as like a lab plus a homework in DSC 10 terms. Okay, so labs are where you're going to get most of your hands-on experience with everything we talk about in the course. And they will typically be due weekly on Mondays, though in weeks that we don't have class on Mondays because of the holidays, they'll be due on Tuesdays. The first lab will explain all of this, but two things I wanted to point out. One, labs do have hidden tests in this class. And two things here. You are actually going to write all of your code in this class, not in a Jupyter notebook. Instead, what you are going to submit for your labs and your projects is just a .py file. Okay, and so the reason for this is to give you experience with interchanging between a notebook and Python scripts. And I can say this firsthand from overseeing the capstone program now. It's really valuable to be able to take code that you write in a notebook in experimental form and put it in a Python file, because when you need to run code on servers for hours and hours, these can't all run Jupyter notebooks, right? You need to have everything in just a Python file and be able to send that to someone else to run for you. And so in this class, you're going to get experience with testing some things out in a notebook and iteratively moving that code to a .py file, and then you're going to submit to us just your .py file. And labs and projects, for the most part, will both work this way. Also, I'll point out that while you use Git to access the assignments, you will not use it to submit the assignments. You will just submit your .py files directly to Gradescope. Again, the first lab will talk about all this. I just wanted to mention it here. So in addition to labs, which you will have weekly, there are also 5 projects which are due bi-weekly, usually on Thursdays. And these labs typically have, these projects typically have a checkpoint that is due the week before the project is due. And the purpose of the checkpoint is to ensure that you've actually started working on the project. Right? And the reason we do this is because the projects are quite substantial. Okay, and you really cannot leave them to the last minute and expect to succeed. Right? And so we're forcing you to get started a week early and submit something just to make sure you're on the right track. Okay. Now, there's something new we're trying this quarter in the context of discussions. Question? Yeah. Right, so both in labs and projects, you will not see your score until after we release grades, which will be after the deadline. So you're going to have to get used to, as you did in DSC 20 and 30, testing your code yourself. Okay, so you know lecture is here. You've all made it here. Discussion is also here on Wednesdays starting next week from 5 to 6 p.m. or 5 to 5:50. Now, when I taught DSC 80 last time, I just didn't feel like discussions were a good use of staff's time or students' time. It was kind of just a rehash of lecture. So we're trying something new this quarter, and we hope that it'll work well for your learning. So here's how it's going to work. Each week on Monday, you're going to submit a lab assignment. Okay? And how this will work is on Wednesday, you will come to discussion and we will take up that same lab assignment or some subset of it. And so our course staff will come here, they will walk you through their solution, they will encourage you to share your solution, and the idea is to think about different ways that you could approach these problems, right? Because even if you pass all auto-grader test cases, it doesn't mean you approach the problem most efficiently, right? In some instances, you might have used a for loop when it turns out that there's a pandas function or a pandas method that does it much more efficiently, right? You may have passed all the test cases, but that's not the way you were supposed to approach the problem, right? So to force you to reflect on what you've done, you'll come to discussion where we will take up the most recent lab assignment and encourage you to reflect. Now, to sort of gauge how much you sort of took away from the lab section, we're then going to release a lab reflection form, which you will fill out, and it'll ask you about the questions we took up in discussion, and it'll say, hey, in what ways could you have improved your solution? In what way was your solution better than any of the other ones you heard, right? And so if you do these three things, you submit the lab, you come to discussion, where we'll take attendance, and you submit the lab reflection form, if you do all those three things in a given week, you will earn 0.3% of extra credit added to your overall grade. Right? We're offering this extra credit because it's a new format, and we really want people to come just to see whether or not it's effective. And so you will be rewarded by coming, of course, first from the knowledge you'll gain by reflecting on your solutions, but also in terms of extra credit added to your overall grade. Now, this plan may change in some weeks, like for instance, the weeks in which the labs are due Tuesday, we'll work something out, but this is the general plan for extra credit, and it's really meant to emphasize the fact that you need to learn from your mistakes on labs and projects. Questions with this idea? All right. There are two exams, midterm and final. They will both be in person. The midterm will be during lecture in week 6 on February 15th. And the final, don't know where it is yet, but it'll be on Wednesday of finals week. And we'll let you know when we have location details. Let us know if you have a conflict. What I will point out is that this quarter we've decided to emphasize exams less in your grade compared to previous quarters. I think the last time I taught this, the midterm was 15% and the final was 25% or something like that. Right? And that's really meant to reflect the fact that you will spend most of your time in this course working on assignments. Okay? So to summarize everything I just talked about, here's what a typical week will look like in DSC 80. Not every week, right? Sometimes things may change, right? In some weeks we don't have class on Mondays. This is typically what the schedule is going to look like. Okay, so Lab 1 is going to come out tomorrow, and Project 1 will come out over the weekend. Okay? Now, how are you going to get help from us? Well, before I get to that, I'll point out some resources. So your main resource for learning the content itself in this course will be the lecture notebooks, and I think the easiest way to interface with them is with these HTML previews that I've posted on the course website. You can take notes with those and do whatever you want. Like I said, we also have a set of supplemental readings at notes.dsc80.com, though many of the lessons, especially towards the end of the quarter, don't yet have notes here, and so for those, I would refer to, well, actually in general, I would refer to the lecture notebooks as your first source of information. There are a variety of other resources you might want to refer to. There are some more classical textbooks like Python for data analysis. There's the DSC 10 course notes, which you might want to look at for a refresher on baby pandas. You could also just go to dsc10.com and see what they're doing there. There are a few other online textbooks, and as we find more resources, we will put them on the resources tab. One thing I'll point out, I'll probably emphasize this more later on in the quarter, but it's called Pandas Tutor. Now, in DSC 20, you learned about Python Tutor, right? It drew the list box diagrams for you and things like that. Pandas Tutor does that, but for pandas. Okay, and there's actually a way to enable it within your Jupyter notebook, and I'll show you more about that in the coming weeks. Okay, now, as I've kind of implied in this lecture so far, and as you've probably heard from other people, this course is a lot of work, right? I'm not making it a lot of work just because I think it's funny. Instead, it's a lot of work because that's really the only way to internalize the material that we're covering. Right? There are so many different topics. each of those topics needs to be tested through these assignments thoroughly, and so that involves you doing a lot of practical work. But like I said, when you complete this course in 2 months from now, you'll leave being able to do tons of things that you just had no idea how to do right now today, right? So it'll be a lot of work, but hopefully it'll be worth it. But in that time, we don't want you just to be stuck on the same problem for 5 hours and say, okay, DSC 80 is taking me 5 hours, right? While it is true that learning how to unblock yourself from a problem is a skill, we of course offer office hours, all throughout the day, especially on deadline days, where you can come and say, okay, here's a problem I ran into. Here's what I tried. I didn't just come up with the problem and come to you. I tried some things. What should I do from here, right? Ed is also your friend. We just ask that if you're posting questions with your personal code, make those private. Otherwise, your questions can be public, especially if they're conceptual. Please make those public because others will benefit from the responses. Okay, one other thing I'll mention, you will learn to heavily rely on documentation. Okay, I'll say that from day one. There are going to be things, even on the first lab, that we're just not going to talk about in lecture. We don't have time to talk about every single pandas method, and even if we did, it wouldn't be a good use of our time. Right? So you're going to have to learn how to say, how do I do XYZ in pandas? And search the pandas documentation, and search the NumPy documentation. Right? So just be warned that that is part of this course. It's not accidental, like we didn't forget to explain something. It is an intentional learning objective to learn how to work with documentation. Okay. Just to drive the point home, you're going to work a lot in this course. But the last time I taught it, people left the course being pretty happy. They didn't seem to like me for some reason, but they liked the course. Okay? Any questions logistically with what's going to happen in DSC 80? Yeah. We got a question? Yeah. So discussions start next week. Yeah, good question. Okay. I don't know what's so funny. So before we look at this cool example that I'm really excited to share with you, what I want to introduce in lecture 1 is this useful pedagogical tool called the data science lifecycle. And to motivate it, I want to introduce the scientific method which you learned about in your elementary or high school science classes. Right? You learned that in chemistry when you're doing an experiment, or in biology when you have a question, what do? Well, you take your question, you somehow model some data, and then you come to a conclusion. And for relatively simple problems, that works fine, right? But now that we're becoming more mature students, I think there are some flaws or some holes in this picture with the scientific method, right? Where did that question come from? Right? Often in elementary school classes or high school classes, or even in DSC 10, you didn't really have to think about what questions to ask. Right? They were kind of just provided to you. But where do these questions come from? How do you come up with a good question to ask? It's the kind of thing we will look at how to do in DSC 80. What data do we have access to? Can our data even answer the questions that we want to try and ask? Do we have to go and collect new data? Right? It's another axis in this space that we just never thought about before, but we will have to think about now. Right? Even if we come up with a conclusion, when is that conclusion valid? Is it always valid, or is it only valid under a certain set of assumptions? Right? And so this is the before, this is the after. Okay, and so this is what we call the data science lifecycle. And what you'll notice is that all steps of the data science lifecycle, except at the very, very end, all steps point back to asking more questions. So even after we acquire data and clean it with the purpose of answering one question, several other questions will arise, and then we'll just find ourselves navigating endlessly through this loop. Okay, but this really highlights the complexity involved in data science problems. Right? You don't just have one question and come up with one answer to it. Right? How you collect the data, well, that introduces a bunch of questions. And at each step, more questions arise. Okay? So we're not going to come back to the data science lifecycle for another few weeks. And that's because we're going to spend most of our time right now on the find and clean data step. We're going to do quite a bit of that, and some of the data modeling. But later on in the quarter, we will be sure to touch all of these points in the lifecycle, including reports or decisions. One of the things we're trying for projects 3 and 5 this quarter is having you create public-facing websites with interactive visualizations for your projects. Okay, so you're going to do all of this quarter. Now, with the remaining 10 minutes, I just want to show you a cool example, just because I think it's cool. And it motivates the kinds of things that you will be able to do in just a few short months. Has anyone heard of the site MyFlightRadar24? Okay, one person. Well, you may have heard of FlightRadar24 or FlightAware. It's those sites that allow you to track any plane if you have the flight number. Right? People do things like they track, where Elon Musk is, because they care about that for some reason, or whatever, right? But MyFlightRadar24 is this site. It's free to use, and it allows you to enter every flight that you've been on. And what it does is it creates these cool visualizations. Like, for instance, this is my personal MyFlightRadar data. It shows every flight I've ever been on. Not ever, but it has every flight since 2014 and some of the flights before that, right? Like, it doesn't have when I went to India when I was 1 year old, because I don't know where the proof of that flight would be. But every time that I booked a flight, it's here, right? And so it gives you this cool map, and you can see there's actually a scheme to the color, though you kind of have to know a bit more about the data to know that. Some routes are in black. You can see that this one over here is in black. And that is where I go every time I go back from San Diego back to my home airport, which is Detroit, which is right next to Canada, right? A lot of these are in red. The red lines are routes that I've gone on more than once, and some of these are orange, which are routes that I've only been on once. Okay, so that's how it comes up with the colors for this map. It also has a bunch of other things like your top airports, your top countries, your number of flights per year, things like that. Now, if you had access to this raw data, if you had access to this raw data, knowing what you know from DSC 10, you could recreate any of these plots, right? Maybe not interactively, but you can make them using dot plot kind equals bar h, right? What you can't do is make this plot, and what we're going to do with our remaining 8 minutes is recreate this plot here. You had a question? Yeah, okay. So there are paid apps that do this automatically now if you connect it to your email, but I loaded the bulk of the flights here in the summer between graduating school and starting at UCSD when I had literally nothing else to do. And so I spent hours like searching every email and entering every flight number. But now I've gotten in the habit, every time I land on a flight, I just go here, click add flight, and put the details in. But yes, I had to do this manually. Yeah. Okay, so like I said, we are going to recreate this plot. And the thing to remember is that the colors of these lines are not arbitrary. There's a pattern to the colors, and we're going to need that in a second. So we're going to try and recreate it. And fortunately, MyFlightRadar lets you download a CSV of the data that you've uploaded. Okay? So I've loaded in this as a pandas data frame. Don't worry too much about the code here. Just think about conceptually what we're doing at each step. But this is a pandas data frame, not all that different from a baby pandas data frame, which you know all about. Okay? What is this telling me? Yeah, it's the number of rows and columns in this data frame. So it has information about 149 flights, and there's 19 pieces of information for each flight. Now, remember, our goal is to make this. So the first thing, well, think of this as step 0. But the first thing to note is that there's a lot of unrelated information, like what aircraft I was on each flight. We don't really care about that right now, so I'm just going to select only the columns I care about. Note that you didn't have to use .get here. There's this other syntax for it. We'll talk about that on Wednesday. And now I have 1 row per flight, and I have the from airport, the to airport, so on and so forth. Now here's the first thing I want to do. While these names are descriptive, like San Diego / San Diego International, SAN/KSAN, it's a little inconvenient to have these long names everywhere. It would be nice if I could just extract the canonical 3-letter code for each airport, like SAN or DTW or SFO. Okay, those are formally called the IATA codes, IATA codes of the airports. And so I want to be able to take a string like San Diego / San Diego International, SAN/KSAN, and extract just out SAN. Now, later on in the quarter, we're going to learn about regular expressions, which are a robust way of extracting this kind of thing out. But we can do this without knowing about regular expressions. And in fact, I've already done this for us here. Could someone walk me through how this function works? Like, explain what this is doing. Yeah. Correct? Exactly. So this is looking in the string. It's finding the first left parenthesis. It's finding the index of that. It's saying, okay, well, the three-letter code is going to start right after that. And then it's finding where the last slash is in the string. Right? There's a difference between find and rfind. Rfind starts at the end. Find starts at the front. Right? And so it starts at the first left parenthesis and goes all the way to the slash, and it takes everything in between. Now, this worked in the SAN case, but can you imagine a case where this wouldn't work? Can you think of a string for which this would not work correctly? But it also wouldn't work if there's a parenthesis earlier in the name, right? However, I tried this out in advance, and this worked for every airport code I had, though you can already see that this is not that robust. Later on in the quarter, you'll learn about regular expressions, and it would handle edge cases like that. And so what I'm now going to do is take my flights data frame. .head, by the way, just shows you the first some number of rows in your data frame. And I'm going to apply this function to every item in the from column and in the to column. And when I do that, my new data frame is a bit more compact. Right? So now I don't have these long names. Now I just have things like YQG and YVR. Okay. Now, what's the next step? Because the colors depend on how many times I've been on each route. So what should we do now? Yeah, we need a group so that we have one row for every pair of airports. Right? One row for SFO to SAM. One row for LAX to JFK, so on and so forth. And so I can do that. I'll group by, because remember, when you group by some column, you get one row for every unique value in that column. When you group by two columns, in this case I'm grouping by from and to, I get one row for every unique combination of values in those two columns. And so again, don't worry too much about the code. We'll spend quite a bit of time on it. But I've done that here, so now I have one row for every unique combination of from and to. But what's the issue with this data frame? I don't have the other columns, but I actually don't need those for the plot. But remember, in the map, there's only one line per pair of airports. Right? For instance, here, I don't know if this is Detroit to Atlanta or Atlanta to Detroit. Right? It's just a line between them. But here, my data set has one row for every unique combination of from and to. So the first two rows both correspond to the same line. And rows 3 and 4 also correspond to the same line. So I need a way of combining all of this information. Now, there are a variety of ways you could do this, but what I'm going to do is come up with a way of coming up with like a serial number for every unique pair of airports. So for this one, the serial number, or code, will just be DTW-SFO. And this one, I'll also make it DTW-SFO. And the way I create these is by saying, well, take the one that's first alphabetically and put it first. So then these two rows will have the same value, and then I can group again. Okay? So that's all I'm going to do here. And so now, these two rows have the same serial number. These two rows have the same serial number, so on and so forth. Now I can group by this both column again. And now I have the number of times I went on each route. So we're almost there. How much time do we have? 90 seconds. We'll try. Okay. So now, this is about all the data we have, but we need to be able to make this map. Right? So something drastic has to happen in the next 90 seconds. Well, how is that going to happen? Well, we need to know where each airport actually is. Right? We don't have that information right now, but we can load in a data set with that information, which I happen to have. So from that data set, I will keep just the relevant columns, so latitude, longitude, and IATA code. The first 5 in the data set are kind of irrelevant. You can imagine somewhere in here there's an SAN, there's a JFK, whatever. And what I need to do is combine this data set with the one back here. Now, there are a few ways you can do that. The way that you might initially think of is using the .merge method. But there are a few other ways. In this case, I'm actually creating a dictionary and looking up in that dictionary. So I made a dictionary with the latitude and longitude of each airport code. And then for each airport code, I'm looking in that dictionary to say, hey, where is that airport? And now I have the locations of each airport. We're getting closer. Bear with me for a sec. Now we need to be able to draw maps. And to do that, I'm going to use this library called Folium. And in Folium, all you do to create a map is just say folium.map. Okay? You provided a center where you want to center your map. I put my hometown, which is right here. And then you tell it how big you want your map to be and how zoomed in you want it to be. So if I want it to be really zoomed in, I could put 10, and you can see it's zoomed in a lot on my hometown. 2 seems like a reasonable amount because it kind of matches this one. Well, at least when I zoom in. Now, lastly, I just need to figure out how to put lines on this map, right? And it turns out that there's a method that you find by reading the documentation. It's called folium.polyline. So what I'm doing is I'm taking this location to this location, and I'm drawing a line between those 2 points. And if you know anything about geography, you'll know that this goes from the San Francisco airport to the Detroit airport. So we're almost there. All we need to do now is do this once for every row in the both counts data frame, and then color the rows accordingly, or color the lines accordingly. So I've written a function that takes in a count and returns the color, black, purple, red, or orange, and then in a for loop draws the line for each row in this data frame. And when I do that, boom. That's all it takes. And the colors do match this one. Now there's 2 big gaps that our map does not have that the professional one does. What are they? There are no markers at the airports, right? Like I don't know what airport this is. And it also doesn't use the great circle line around the Earth, right? If you look at this really high line, it goes from Amsterdam to Portland, which like passes over Greenland. But that line here is just, it's straight, which is not actually the shortest line between Amsterdam and Portland. There's a Python module that calculates that great circle line between any 2 points, so we could use that here. Now you probably have better things to do, but if you don't, make those improvements and email me and I'll take a look at it. That's it. We'll be back on Wednesday. Also on Wednesday, we will have a brief announcement by Kelly Jensen, our career services advisor, who will talk about her resources for finding internships and research projects and things like that. Okay, we'll see you back here on Wednesday.